This video tutorial discusses vector cutting file preparation within Rhinoceros 3D for eventual laser output on a 36-inch by 24-inch, 75-watt Epilog Legend laser system. Rhinoceros 3D modeling experience is required. Basic file preparation. To begin, let's create some equipment boundaries. Start by creating a rectangle that indicates the size of your equipment bed. We are preparing a file for our DFAB 36-inch by 24-inch 75-watt Epilog Legend laser system. Therefore, your rectangle should be 36 inches in the X direction and 24 inches in the Y. Our bed size is indicated by the blue rectangle in this file. Next, create a polyline that indicates your material size. In most cases, your material may take up the entire bed, or you may have a sheet that is square, but there are occasional scenarios that involve used materials. We create our material size to improve the preparation process. This will allow for easy recognition of where our material boundaries are located, and more importantly, it will allow for easy nesting of any geometry we are looking to cut. Our stock is indicated by the magenta geometry in this file. A few tips before we move on. It is a good idea to begin organizing geometry onto layers. It helps in several ways. And if we use this file as reference, we can see that my constant values, such as bed size, are separate from my sheet layers. This way I can prepare several files for the laser cutter before sending them. It is also useful to expand your top viewport. The laser system will process two-dimensional geometry, so preparing and working in a two-dimensional viewport makes things less complicated. Lastly, realize where your equipment origin point is located. The top left of the bed on our Epilog is considered the X and Y 0. This means that our stock should be squared up and positioned in reference to this point. It is not necessary for your bed or stock size geometry to reference the origin point on the C-plane or the grid in Rhino. This can be positioned anywhere on the grid. We will discuss this reasoning later on in the tutorial. Geometry requirements and properties. To process geometry that cuts through material, we must define our geometry as vector. Vector geometry requires a print width of 1/1000th of an inch or 10/1000ths of a point. Usually in vector-based programs like Rhino or AutoCAD, vector print widths are indicated by the value hairline. Additionally, it is typically the case that vector-based programs create hairline geometry by default. This means any line you draw will default to the layer's default print width value, and the layer's default print width is more often than not set to hairline. If we want to make sure our geometry is set to the correct print width, or if we want to change the print width in Rhino, we have to open the object's property menu. You can do this by typing in Properties into the command prompt, then selecting the geometry you want to edit. In the Properties menu, we find several object settings and values, but we are looking to correct the print width value. If we select the drop-down menu next to the print width option, we receive a list of the most commonly used choices. If your Rhino and layer settings are default and you haven't changed them, then selecting the by layer default or by parent options are all acceptable. If you are importing a file, or if you are unsure of the default settings of your layer or Rhino options, then selecting the hairline option will be acceptable. Simply put, no matter what the scenario, if you select the hairline option, your geometry will cut when processed by the laser equipment. You may also notice an option at the very bottom of your print width drop-down menu called No Print. This option is very useful. For example, we don't want to cut our bed or stock size reference geometry, but we still need it visible for reference. If we select this geometry and change its print width to No Print, then it won't print. You can also do this for any other reference geometry you would prefer not to print. Printing. Once your file is adequately prepared, we can begin the printing process. From the File menu, locate the Print option. When we select this option, it will open a new window where we can set up our print settings. Our print setup window is divided into 6 tabs, most of which are left as default settings. To begin, locate and expand the Destination tab. Start from the top by making sure the correct destination has been set. we want to print to the Epilog engraver. Other options located in this menu are typically default or unimportant. However, there is one specific property menu that controls how our file will be processed. Locate the Properties button within the Destination menu. Once selected, the Properties menu appears as a separate window. This window is referred to as the Epilog dashboard. The dashboard is relatively simple to understand, but we'll briefly discuss the options that are available to you from this menu. Starting from the leftmost top portion of this window, we'll begin with our resolution settings. Resolution is only important if you are raster engraving. If you are vector cutting, this setting is useless. Very simply, the higher the resolution, the better your engraving. Keep in mind that if you use a high resolution, like 1200 or 600, your file will take longer to engrave. Below resolution is the options area. The autofocus option allows for the laser head to adjust itself to the correct height above your material. The laser head should always be 1.5 inches above your material. By selecting the autofocus option, before the file runs, the laser head will determine the correct height based on your material thickness. If we cut 1/4 inch thick material versus 1/16 inch material, the laser head needs to focus itself to the difference of these thicknesses. By default, in DFAB, all users should have this setting selected. Center engraving allows us to center our engraving geometry or image to the center of our material. You can choose different centering options, but this is only necessary for raster engraving. In the top center, we find our job type settings. If you are only engraving, then you select the raster option. If you are using vector geometry to cut or score material, then you select the vector option. If you plan on doing a little of both, then choose the combined option. If you select the combined option and you don't have any raster geometry, it will not attempt to cut anything as raster, and vice versa. Below job type is our piece size. It is useful and less complicated if you set this option to the size of your equipment bed. The DFAB Epilog systems have 36-inch horizontal by 24-inch vertical beds. This will come into play later on. Lastly, we find our raster and vector settings. If you aren't engraving, there is no need to set any of the raster settings. Alternately, if you aren't vector cutting or scoring, then there is no need to set vector settings. Let's begin by discussing the values we use to program the raster or vector settings. Speed will determine how fast the laser head moves while cutting or engraving any geometry. Power will determine how strong the laser will cut or engrave. Our last value is frequency. Frequency is not an option for raster engraving. The best way to explain frequency is in terms of real-life objects. For instance, if we turn on a water faucet, the more we turn the handle, the more the water flows. Turning the faucet knob slightly only allows for minimal water flow. Higher frequency relates to more laser flow, and lower frequency is less laser output. We determine these values based on the density of our material. If we plan on cutting cardboard or a paper product, then we use lower frequency. Higher frequency applies to dense products like acrylic and lumber. It can be difficult to remember these values and settings. Therefore, DFAB has saved presets for many of the most commonly used laser materials. If we browse to the top of our Epilog dashboard and select the Advanced tab, we find a new window with a list of presets on the right. If you plan on using these presets, you must know what material you plan on cutting or engraving, and its thickness. Load the preset by selecting your desired option and pressing the Load button. When we return back to our General tab, we will find the settings have been loaded. Once we've correctly set up our printer properties from the Epilog dashboard, we can select the OK button to exit. Our last setting is located in the View and Output Scale tab from the Print Setup menu. Find and expand this tab. Here we adjust our print view. If we look to the right of our Print Setup menu, we find a blank screen. This is our print preview. Obviously, if there isn't anything appearing, then we aren't going to cut anything. The most efficient way to adjust your print view is by setting the View option to Top. Next, select the Window option below. Then select the New or Move option below that. When we select Move or New, it will return us back to the Rhino screen. Pay attention to your command prompt. It will provide instruction. Usually, if we set our piece size settings correctly in the Epilog dashboard, all we have to do is move our print window. Your print window is a semi-transparent white area located in the top viewport of your Rhino screen. Anything within the print window will be sent to the laser system. The print window is conveniently moved by turning on your Object Snap Endpoint option and selecting any corner of the print window. You can snap your print window to the rectangle you've created to simulate your bed size. This is where the simulation bed size rectangle and the piece size settings you've set from the Epilog dashboard come into play. It provides a quick and efficient method of setting your print window. Once you've moved this window, press Enter and you will return to your print setup screen. Notice that the print preview on the right includes all geometry within your print window. From this point, you may choose to close this print setup menu to edit your geometry in Rhino. It will save all of your current settings. Alternately, you may be ready to print, in which case select the print option from the bottom right of your print setup screen. This concludes our session. If you followed along, you should leave with a basic understanding of how to prepare a Rhino file for vector cutting. The Digital Fabrication Lab operates within the School of Architecture at Carnegie Mellon University. Visit us on the web at www.cmu-dfab.com for more DFAB video tutorials, resources, images, and information.